Labeling point cloud is a real pain, especially for geospatial application when you have massive point cloud. Let me show you here my specific workflow that I use in production that has two main goals. The first one is to automate a 3D processing pipeline, and the second one is to create super nice labeled dataset for training 3D deep learning models. So the mission that we'll go through is to go from this kind of point cloud, another one, into this super nice labeled dataset with as minimal time as possible by leveraging unsupervised learning algorithm and smart tricks with CloudCompare. Whenever you're ready, let's roll. So we are here. Our input data is right in this folder and CloudCompare is open. So I just drag and drop my file in CloudCompare. I make the shift and this is where we arrive. So the first thing to do is to improve visibility. I just select my point cloud and in my Scala field, you can see in here that I have a lot of range that is not really useful. So we'll just copy that value now and paste it here, press enter. And this is already better. The second thing that I should do is maybe change the coloring to another type of coloring. So in here, for example, we are much better, increase the size of point. It will be much easier for us to go on to the next stages. So what is super important now that we have our point cloud, you can see that it's a complicated one for an outdoor dataset, and there are a lot of classes. Let's define the classes that we will be interested in. So why using Excel or something like this is if you need to reorder the numbering of the classes, that's easy to do. So that will be the classes that we want to build. So first thing off is in here, checking in if we have a classification field, we could use that. So in here we have a classification that was from an automated deep learning approach. It's not perfect, but we could use that as a base. In here I want to start from scratch, so I will just go into edit Scala field, delete this one. Okay, so at this stage what we do is we'll select our point cloud and open the cloud layer tool that you can also find in the plugin Cloud Layers. Very cool stuff. Just be a bit careful, sometimes it's a bit unstable. I already had 3 crashes by trying to delete a number of these classes. So know that when you arrive there you have already existing classes. This is from the ARSPRS standards, so you can use that, but because we have our classes on the left, we will use that. So what I do is basically renaming that. For now they are all in unclassified. You are free to change the colors or anything else, but at this stage we are okay with the definition of classes. So now what we do is we can take all of these classes and create a note, like for example with this, and in here we just drop in our classes. I will add class definition, right? And on the left side, this is the index and this is the name. Okay. So, and here. Okay. So I can close that. I can close that. I don't save it at this stage. And now if I open my folder, you can see that I have my class definition. Okay, so we are good to go in here. We can move on to the analysis of a point cloud. So let me take it again and change the Scala field to our intensity value. We don't have color, right? It's an MLS point cloud. Okay, so what can we see? The ground is not straight, and what is, for example, in here the curb height? That could be an interesting thing. So if I go there, it should be around 10, I guess. So 15 centimeter. That is good. And for the noise level, you can see that we have almost no noise. So it's a pretty precise point cloud, and we have some floating points. Okay, so let's move on to the strategy. What I can highlight is your algorithm toolbox, things that we can leverage to accelerate our semi-automated unsupervised segmentation and labeling. And for that, you have the CSF filter that would be really handy whenever you want to delineate the ground that is not perfectly flat. You have the Ransac shape detection toolbox. This allows to like delineate or detect specific shapes like planes, spheres, cones in your point cloud. We have also the connected component. So in here you have to imagine you create a voxel grid, and on top of that, so let me showcase maybe most of the things. So this is the voxel grid. If I go onto a top view, right, and I will just go into a higher level. Basically, this is what the connected component does. Depending on the level of your octree, so here I'm at level 6, you see that you have points that have no connected component when we look at this, and here it's a massive connected component. So it means that whenever we'll have clear Euclidean delineation, we can use that very efficiently to get floating elements and like analyze them independently, which is super cool. Really handy stuff. So let me just move around, and the last stage is leveraging the feature and doing thresholding. So a bit like I did with intensity, right, where you can threshold, then after the thresholding you can basically filter by value and export a specific kind of filtering in here. So there, for example, the point in gray that I would filter, right, and maybe then I could work only on that. So that means that all the things that are with a high intensity, I could work only with that. That's the toolbox. Now I will show you a strategy where we will first detect the main host, then the secondary element, and then we'll work with the remaining element before moving on to the secondary and the main host and labeling that. Okay, so how does that start? I will, at this stage, what I do is use the CSF, okay? So in here you have some parameters like the cloth resolution, the max iteration, and the classification threshold. I like to export the cloth mesh so that I can show you. If you go very low, basically you model from below, you model a mesh with this specific resolution. That's the number of iteration. And then once you have the mesh, you compute the distance from the point to the mesh. If it's below this threshold, you add it to the ground entirety. So if I were to put a very tiny cloth resolution, let's say 0.5, we'll have all the variation, and that should not be very efficient with a 10 centimeter. And you can see that this is what you model, okay? So if I look at the delineation, you may not have something super, well, it's actually pretty nice. You just have some walls that were taken inside. Okay, so let me delete that and move around and use maybe a parameter that is a bit bigger. So 2 will be good, and classification 1 is also okay. And I will go with a bit more iteration, which means that now I have my ground point and my off ground point. This is fine. I know that I will have to rework a bit here, but at this stage I'm pretty happy with the results, right? Ground point, yeah, this is pretty good. So now I will, at this stage, create a folder, like labeled PCD, and every time I have something, so I will, in this folder, I will create 2 folders, work in progress, and done. And these 2, I put them inside. So this is things that I have that I can get back to. So maybe I can add the raw point cloud so that if there is a crash, I can reuse it, and the raw, I will have it below. This is the raw point cloud. I don't need it. And this is at this stage, the ground point. I will have to work with that, and of ground point also. And in the work in progress, I will add to do so that it's easier for me to handle. And the ground point, I put that in to do so that every time I have something, I can highlight everything that is in this folder. And now I will start working with that. So we have our organization nicely done. I will just save it in our folder so that if there is a crash, we can reopen it, select the folder, file, save, and I save. Okay, so we're good. Now, second stage, secondary elements. So what I do is I will here leverage Ransac, so multiple Ransac algorithm. Some elements that I want you to take care of is the minimum support point primitive. I want a lot of point in here because I just want basically to get mostly the two lines that will be hard to delineate at this stage. And I just want planes. Distance to primitive, this is something that should be taken care of. So if I were to be very, very tiny, I will have only the point really on the facade. But here I really want to have all the points. So that means that I need to know more or less what is the size of this wall. And this is just the point. Let me take the distance. So our walls is around like 20 centimeter maybe. So if I take 15, it's good. I will have a bit of a buffer, but that's fine for me. I think you can go a bit below. That's up to us. So let me select it, Ransac, and in here, yeah, okay. Why should we go like around exactly the size? Because whenever you have the plane, this is computing on both sides. So if your walls is 20 centimeter, and you want to have the plane that takes only this point, you need to set a threshold to 10 centimeter, because mostly the plane may be on the middle, or maybe it's on the facade. So this is why maybe take something that is in between, so like the size of your walls, that will be fine. And the max normal deviation, as I mentioned, if you want also to check the normal deviation to your plane, this is an additional criteria. Leave it like 25 degrees is really nice, but in here I don't want to use that, so I make 90 degrees. So whichever normal we have will include all the points that fall within the plane, depending on the threshold. So if I do that, I put that to 10,000. I want to save leftover points in a new cloud, and I don't need to simplify shape. I could have random colors, but let me take that out for now. And I think we are good to go. We just keep the plane and we run it. So it goes pretty quickly. And as you can see in here, we have several planes that were detected that we'll be able to use for our analysis. So one thing that we need to be careful about is this little plane here. There are two planes and I don't really know why. And we have to ensure that we have all the points on our wall. So to ensure this, you can see that now in the exploration database tree, we have a lot of planes with points. So one thing that we can do is just to select them all, put toggle so that they are not there, and check out the leftovers. So that's all the points that were not taken into account. And for me, it looks fine because we don't have a lot of points that should belong to the facade. Something that you may find weird is now, it looks like depending on my view, the color of the point change, which is normal because it computed the normals to check that. If you want to deactivate that, just click in here and this will be back to what we had before. So at this stage, I'm pretty happy. So it means that this leftovers will be the thing that I need to have in work in progress, and the off-ground point like holds everything. So this is to be added to a folder done. So we don't want to duplicate, right? So the off-ground point are actually delineated into leftovers and all the planes. So if we were to keep that here, we'll have a problem. So I just create a done duplicate folder, and I will move that in here, and basically this Ransac shape detected thing, I will move that into to do, and we are good. If I were to highlight everything in to do, we have all the other elements and here the leftovers, right? And that is if we need that thereafter. Okay, so let me just go on to the leftovers and check out if we can do anything with that yet. So there is one thing, it's that actually the line may be a bit problematic. but that's fine. And then we have some other elements. That's also fine. I will show you now how we can deal with that like quickly enough, but I will use colors. Be careful not to use that for your own purposes, because else you will delete RGB if you had RGB. I don't have RGB, so I can't do that. So what I do is I use the connected component functionality, which is here. And at this stage, I want to make sure that I have a minimum number of points per component. Be wary that if you do that, you will delete a lot of points that we may want to keep whenever we have a component that have less than 10 points. So be very careful with that. But if you put 1, you will delete nothing. The problem is you will have a lot of tangible or possible segments that will be created. So we have to be careful with that as well. So minimum point per component, I will put 10, put the random colors, and I will stay at a grid step of 7 for now, which is good enough not to have too many segments. Very good. So what I do in here is just make sure that all the tiny classes that are here are in one class. So I will select that. Very good. I will select that, that, and that. Really nice. Also that and that. And I will then combine it. I want to generate a scalar field. No. And this is wires for now. So I will continue working in this folder. All the rest at this stage, I will call that remaining and keep the index. So that, yes, remaining. So we finished with the leftovers, and basically that means that we can move that to done duplicate and move leftovers to do. What should we do now is move on to the Ransac shape detected and like study each one of them. So there is one thing that is very interesting is, for example, let me take this one. So I will just untoggle the other one, toggle, take this one, and you see that you have a plane that is created. So what I like to do is align camera and then deactivate the plane. So this will be much easier for us to label what is in this cloud, right? So all you have to do is select your point cloud and use the cloud layer and then color points. Before starting, I will, as input class, all the point, and output class, I want to go into walls. So I just go to walls, right? And I start coloring. So you see that if I increase with the mouse or decrease, you have a little circle that is big or not. So for now, we'll take the big one and I go like this. This is for the walls. So whenever I'm ready, I press OK, and this is in the walls category. Now I reopen it, and basically all that is not a wall, so input class unclassified, right? This will be all the rest. So let me take again the pen, put pause, just make sure that goes into wires. And here we go. And as you can see, I can go everywhere. You just take the remaining point. Okay. So this is a bit of a mistake. So pause, wire and to wall, sorry. And now I put walls to wire. So this one is done, right? This plane. So what I can do is put that into done. and move on to the second one. Same thing, align camera, deactivate, and here we have a bit more stuff. So what I can do is select the cloud layer, just put in classified into wire. That is fine. Let me start. Okay, so at this stage, all the Ransac data shape are done, and they are all in the folder done. Now we can move on to the leftovers, right? So in here, we have all the remainings. We'll deal with that later. So all of that are walls. Let us check if it's really walls. So this is the portal. So there's our walls, there's our walls, there's our walls. Yeah, indeed. Everything is walls. So let me uncheck that, take that, and just move on to the cloud layers. Same thing, unclassified, and we will go to walls. This is the easiest way. We could also change the class number, but this is as quick. So this is done. Now we have the wires. This we will deal in 3 classes, right? So remaining is done as well, and all that is left to do is the ground point. Okay, and this is done as well. So all is done. As a measure of precaution, I take all of my point clouds and I duplicate it. I take the duplicate and I merge that. I don't keep the original cloud index, and this is my classified point cloud result. So if there are things that are still to be labeled, we can correct it right away from there. So this is a bit handy. Like, I think all of this is in wire, so this could be modified. Like what I will do now, things that are wire, right? And I want to put that into poles. And here we go, guys. We have our classified point cloud with all our classes that is ready to train a beautiful machine learning model. So the last stage that I do is I put that back into labeled. I save this so that if I need to rework on it, I can. And then this one, file, save, and I export it as LAZ and classified pcd.laz. I save it. version 1.2, format 3. I can leave the origin scale, get the original offset. In the last field, you choose what you want to have. In an extra field, you can also choose if you want to have extra field. So original cloud index, we will remove it, we don't need that. And in the field, we want classification and normals as extra field. If we want Scala field as extra field, it's okay. And RGB, this is also okay. I press OK and move the classified PCD. I apply that, yes to all. We should have our point cloud nicely handled, right? So this is RGB. We want the Scala field, not the intensity, but the classification. And as you can see, our point cloud is classified. And this is like a gold mine. With this, the first hand thing that you can do is train a deep learning model to recognize the specific classes that you have on urban point cloud. So this is the first thing you can do. You can also monetize like your service as a data labeler, or if you want to monetize this data set, this is also something that I've seen, because as you can see, it takes some time if you want to be really precise to make sure that you don't create a garbage data set. So this is very important. This is the hands-on semi-automated method with unsupervised approaches. If you want to move on to something that is fully automated with Python, this is also feasible. I will address some specific aspect, especially tied to this algorithm toolbox, about how you can automate that with Python. And if you already want the full workflow automated, you can go onto learngeodata.eu and find the course 3D Segmenter OS that will allow you to do just that. So this may not seem like a lot, what we've been doing here, but there are so many little tricks, dirty or not dirty tricks, that are hiding within this specific workflow. What I can only encourage you to do is just right away, if you did not already, to take a point cloud and go through that, create your label dataset. That will be super handy for other experiments, or if you really want to make that a product as part of the service offering that you have, or as part of the company that you have. All right. So if that was useful to you, don't hesitate to share that with other like-minded people, and let's see each other in the next tutorial. Bye-bye.